Okay, so in this video, we look at a question on limiting reagent. And from the definition of a limiting reagent, we know that a limiting reagent is just a reactant or a reagent which determines the extent of the reaction. So how far the reaction will go is actually determined by a reactant which is in limited supply. So I have a question which says 2.4 grams of magnesium to react with 0.3 moles of hydrochloric acid. Determine the limiting reagent. Step 1 is we have to write a balanced chemical equation. So we're saying magnesium, okay, so magnesium react with hydrochloric acid, and whenever a metal reacts with an acid, you form a salt and what? And the hydrogen gas, like that. So we are going to form magnesium chloride and hydrogen gas. Let's make sure that this is balanced. So we balance there. Now this equation is what? Is balanced. Of course, this is a solid, this is aqueous, and this is a what? A gas. So now that the equation is balanced, how do we determine the limiting reagent? We've already been given the number of moles of hydrochloric acid to be 0.3 moles. So we need to find the number of moles of what? Magnesium. And we know that number of moles is equal to mass over molar mass. So the mass given here is 2.4 over the molar mass of magnesium is just 24. So if I divide 2.4 by 24, I'm just getting 0.1. So the number of moles of magnesium is 0.1 mole. So I'm getting 0.1 there. Now from here you can actually tell that magnesium has gotten the fewer number of moles as compared to hydrochloric acid. And from here you can conclude that magnesium is a limiting reagent. So from here we can conclude that it is a limiting reagent. But there's another way of confirming that magnesium is indeed a limiting reagent. But in most cases, this is enough to conclude that magnesium is a limiting reagent. Like I said, you can go further here. You can use more ratio, and you can actually come to the conclusion that, okay, this is a limiting reagent. Maybe we should do that. So let's do this. Further, we can confirm actually that the number of moles here, they're actually the one that are in limited supply. How do we do that? We can say, look at the mole ratio, it's 1 to 2, right? So we have 1 for magnesium and 2 for what? For hydrochloric acid. Then we can multiply this. We can multiply this by the one that we need to cancel. We have 0.3 there. We put 0.3 there. This is for hydrochloric acid. So we'll be able to cancel like that, and we'll be able to make that 0.3 multiplied by 0.5. And we're going to get 0.15 moles of what? Magnesium, right? Then we do the same. We have one more. So now we'll swap them. 2 moles will go there, and 1 more. This is for hydrochloric acid. And 1 more of what? Magnesium will come there. But we multiply by the one that is on the bottom. We had 0.1 there. So 0.1 more of what? Of magnesium. So when you cancel there, you discover that you're having 0.2 moles of what? Hydrochloric acid. Now, look. Here we have 0.15 and here we've got 0.1. The question is, what is 0.1 minus 0.15? You discover that you give you a negative number. This is bigger than that. Now, because this number cannot be subtracted from 0.1, this means magnesium is a limiting reagent. Here we've got 0.3 and here we've got 0.2. You can easily find the difference because this number here is larger than that number. Hence, hydrochloric acid is in excess. Magnesium is a limiting. We've further proved that.